In this video, we'll examine the buoyant force. First of all, why does a buoyant force occur? In these three examples, we've got cubes of different materials submersed in liquid. On the left, we've got an extremely light gas, having almost no mass. We want to draw the forces that are acting on this cube and see why they are what they are. So pressure increases with depth. And pressure is caused by the motions and forces that particles exert on each other. So all of the time, these particles are bumping into the cube and exerting forces on it. But we have to remember that the pressure at a lower point in a fluid is going to be higher than it would be at any point above that in the fluid. So we'll have a force pushing up from below, and we'll have a force pushing down from above. But the force pushing down is not as large as the force pushing up. It's because of the difference in pressure between the lower surface and the upper surface. We'll also have some horizontal forces, but they'll cancel. This results in a force directed upward if we sum the upward arrow and the downward arrow. Then what we could do, I'll do it in this next drawing here, is we could just draw one force, which would be called the buoyant force. It's the sum of the upward and downward forces due to pressure. And all the blocks will actually feel it equally. No matter what they're made of. Now we also have to remember that each cube is going to have a weight of its own. How big should the weights be? Well, this one is just an air-filled cube. This one's going to be, let's say, a water-filled cube. And let's say that our fluid is water as well. And then let's say that this cube is actually of metal of some kind. So much more dense. Well, the metal is going to have the largest downward gravitational force. The water, however, will have a downward gravitational force that is equal and opposite to the buoyant force. And air, well, let's say that doesn't have much of a downward force at all. So what's going to happen to each of these cubes? One of them will float because of the forces involved. The other will stay just where it is with no acceleration. And one will sink. Which is which? The air would float. Assuming the difference between the buoyant force and the weight here is negligible, water will remain suspended where it is. With perhaps zero acceleration. And the metal will sink.